Welcome back, everybody. In this video, we're going to do a couple more examples of combinations of functions, and then I'm going to move on to compositions of functions, which is a different topic, but relatable in this lesson. So here's our first example. We're given f of x is equal to 2x plus 1, g of x is equal to x squared plus 2x minus 1, and we're asked to find f plus g of x. Let's go ahead and do this. So we have f plus g of x is going to give us 2x plus 1 plus x squared plus 2x minus 1. We can go ahead and break the parentheses. We're going to get 2x plus 1 plus x squared plus 2x minus 1. If we group like terms, we have x squared in the front. You want to keep that in the front since it has a higher power. X squared plus 2x plus 2x plus 1 minus 1. And we can clean that up. We get x squared plus 4x, and then plus 1 and minus 1 is just 0. So you can go ahead and factor that if you like. You can get x outside, and inside the parentheses you're going to get x plus 4. But usually people just stick with this. Let's do the next example. Given f of x is equal to 4x squared plus 3x minus 1, and g of x is equal to 2 minus x squared. So this is those are two big functions, but fairly easy. We have f of g of x, so we're going to multiply both functions basically. I left this here as a reference, so you can go ahead and look at that. So f of g of x is basically f of x times g of x. So let's go ahead and do that. 4x squared plus 3x minus 1 times 2 minus x squared. We can apply the distributive property here. We're going to get, so 4x squared times, actually I'm going to go ahead and write that out. 4x squared times 2 plus 4x squared times minus x squared plus 3x. I'm going to run out of space here, so let me just move the camera a little bit. So at 3x times 2 plus 3x times negative x squared. We're gonna continue here. So we have a plus sign here. Let's not forget that. But I'll put it down here. We have negative 1 times 2. So negative 1 times 2. Then we have negative 1 times negative x squared. So you're just left with some algebra here, which is not a big deal. You basically done the hard part. But let's just make sure everything is right. So we have 4x squared times 2 plus 4x squared times 2 plus 4x squared times minus x squared plus 3x times 2 plus 3x times negative x squared plus negative 1 times 2 plus negative 1 times negative x squared. So it seems like we did everything right. Let's go ahead and clean this up. We're going to get 8x squared, and we have 4x squared times negative x squared. Well, positive and negative is going to become negative, and we have 4x times x squared. Since we have the same base, we're just going to add the powers. So the 4 stays, and x becomes to the power of 4 plus 3x times 2 is going to give us plus 6x. And then we have plus 3x minus x squared. So it's going to be a negative here. 3 stays, and then x becomes to the power of 3. And we have plus negative 1 times 2 is going to give us negative 2. And then we have negative 1 times negative x squared. Negative and negative is positive. Positive with positive is just going to be positive. So plus x squared. So we can group like terms. Well, we have negative 4x squared outside. So it's going to become negative 4x to the 4th. It's going to become negative 4x to the 4th minus 3x cubed. And we can just scratch that. And then we have 8x squared plus x squared. So it's going to give us plus 9x squared. And then we have positive 6x. And we have negative 2 left hanging there. So this is a big problem, but as you can see, if your algebra is consistent and if everything checks out, you won't really have a problem computing this. So we're gonna go ahead and do the second part of the problem, which is f minus g of negative 1. Let me find the eraser here. I think I dropped it. There we go. So the second part is much simpler than the first one. We have f minus g of negative 1, and we have a value 2 here. So eventually we're gonna end up with a number, not an expression. So 4x squared plus 3x minus 1 minus 2 minus x squared. And you can go ahead and simplify this first. I rather do that, and then plug in negative 1 for x. So we're going to get 4x squared plus 3x minus 1. And then if you break the parentheses and you apply the distributive property for the second parentheses, so we're going to get minus 2 plus x squared. We can simplify this even more, group like terms. We have 4x squared plus x squared. That's just 5x squared plus 3x minus 3. Let me just make sure I did this right. Yep, looks correct. Now we're going to replace -1 5 times -1 squared plus 3 times -1 minus 3. Oh, I think I made a mistake here. Let me just make sure. 4x squared plus 3x minus 1. Oh, looks like I did everything right. So that's going to give us 5 times 1 minus 3 minus 3. So that's basically 5 minus 6, which is just -1. So that's our answer. Now we have f over g of -2. And that's much more simpler than the previous two parts of the problem. We have 4x squared plus 3x minus 1 all over 2 minus x squared. Now we can just replace -2 in for x. We're going to get 4 times -2 squared plus 3 times -2 minus 1 all over 2 minus -2 squared. Now evaluating this, we're going to get, so -2 squared, -2 squared is going to give us 4. 4 times 4 is 16. And then -2 times 3 is going to give us -6. And then we have -1 hanging out there. And then at the bottom we have -2 squared, which is just 4. And we have 2 minus 4. So 16 minus 6 minus 1 is going to give us 9 at the top. And then 2 minus 4 is just -2. And that's our answer. So thanks for watching, everybody. As you can see, you can get easily confused. Just as long as your algebra is right and you stay consistent, you'll be fine. I'll make sure to post more videos of combinations of functions if you need me to. But I'm gonna move on with compositions of functions, which is a relatable topic to this chapter. Please go ahead and hit that subscribe button. That'll help the channel grow more. Also, don't forget to like this video, and we'll see you next time.